All right, good morning, guys. This is for physical science. For you guys will be Monday for my class. It's your second, third period. So here's how this is going to work. I'm going to post a couple of YouTube videos throughout the week for you guys to be able to watch the lesson, kind of see what I would do in class with the PowerPoints, and then do some work that goes along with it. So it being the second semester, we're moving into the chemistry side of things. You say, all right, we didn't get to build a roller coaster. We're going to build a roller coaster towards the end of the year. We'll do that stuff. We'll make sure we get that done. But for now, with this, we're just going to move into the chemistry side of physical science and go from there. So today, what we're going to begin with is the history of the atomic model. You've got a little bit of background knowledge on what the atom was built. I'm going to give you the history of it. And then on Wednesday, you're going to watch a video that goes along with the atomic structure and isotopes. So here's the first video, and here's what I'm going to have you do. Every day you're going to log in, you're going to watch this YouTube video. As you're watching this YouTube video, I can see you're watching it through GoGuardian. Then you're going to work on the assignment. You're going to be on Zoom. You have to log into Zoom to be able to get credit for being there. We will take attendance through Zoom. And once we've taken attendance through the Zoom, you can ask me any questions that you may have after you've watched the video. So, watch the video first, log on to Zoom, complete your work, turn your work in, move on to the next class. Pretty simple, pretty easy. Hopefully we only have to do this for a week and be working. So here's the first thing. So here we go. Talking about the atomic structure and the history of the atom. So if we look at the history of the atom, first thing is the Democritus. Democritus is the guy that he goes and he's the one who coins the term atom. And atom means to be indivisible. You can't break it down any further. And he does this in 400 BC. As he does this in 400 BC, for the most part, this is what we know for like 1,800 years. 1,800 years later, we have pretty much the revolution, the science revolution that comes along when we get to John Dalton. And Dalton gives us 5 theories about the atom. In Dalton's 5 theories of the atom, he says that all matter is composed of extremely small particles called atoms. He used Democritus for that. So there's the number one thing, as he used Democritus. And that is still true today. Number 2, atoms of a given element are in identical size, mass, and properties. Atoms of different elements have different size, mass, and other properties, which is also true. When you think about the periodic table, hydrogen, its atomic number is 1, has an atomic mass of 1. It has 1 proton, 1 neutron, 1 electron. The next guy is helium. 2 protons, 2 electrons, 2 neutrons, okay? And so it goes on and on. So everything is different. They all differ. His next thing John Dalton said was atoms cannot be subdivided, created, or destroyed. One thing that we know they can't be created or destroyed, but we do know they can be subdivided today. So part of that statement was false. And remember, this is in 1808 when we were getting the scientific revolution. Number 4, atoms of different elements combine in simple whole number ratios to form chemical compounds. We know that to be true today. H2O is a chemical compound, water. H2O2, hydrogen peroxide, water. H2O2 is hydrogen peroxide. You think about HCl, hydrochloric acid. All those guys are compounds. They're just different elements that have been combined together. Once they've been combined together to make a different compound. Number 5, chemical reactions or atoms are combined, separated, or rearranged, which is still true. So the only part of Dalton's theory in 1808 that we still don't use today is him talking about them being subdivided. We know today that protons, neutrons, and electrons can be subdivided even further. All right, the protons are made up of quarks. Protons can be made up of quarks. It can be made up of all these different things that really get into some really deep chemistry stuff. That we'll hit on a little bit when you guys get back. The next guy after Dalton we look at was J.J. Thomson. J.J. Thomson, he uses a cathode ray tube. As he uses a cathode ray tube to give us, and he tells us that with this cathode ray tube, he discovers the electron. Because with the electron, I know this picture may be tough to see because it's on the video here, but if we go to the next thing here, this is what a cathode ray tube is. So basically what he did was took this beam of light that gets shot through this cathode ray tube, and he took a negative end of a magnet and he put it up against this, he puts the negative end of the magnet against this beam. The negative end of the magnet made the beam do something. As the beam's going across, the beam either reflected or refracted. So if it was a negative end and it reflected, it went away from it, that meant on the negative end of the magnet that he was holding, when he had the negative end towards it and it reflected, that meant there had to be negative particles inside there. He flipped it around, the positive end of the magnet towards the beam goes up towards the magnet. When the beam would go up towards the magnet, that meant a positive and negative. We all know they attract one another. So positive and negatives attract, negative and a negative repels. So that told him there was some negative particle there inside that cathode ray tube. And that negative particle was what we call that electron today. Okay? So that's J.J. Thomson. Another thing J.J. Thomson, and after he did this, his atomic model, Thomson went on to call this the plum pudding model, that you had basically protons and negative electrons kind of all spaced throughout. He believed the electrons were like plums embedded in a positively charged pudding. That was called that model, okay? So they were just kind of dispersed, which is essentially not very true. We know that electrons are in orbitals now, okay? Or set orbitals, not in set orbitals, but can be in different places. The next guy, we won't talk much about Millikan. He did the oil drop experiment. This one right here is very important for you guys, Rutherford, all right? We go on to Rutherford. Rutherford was the man who ends up discovering, with the gold foil experiment, the proton. If you look at this, all you had to do was take, with this right here, you've got this alpha emitter, so it's a particle emitter. And he put this gold foil, piece of gold foil there. Some of the particles went through the foil, straight through. Some of them reflected, some of them refracted, just like you see on this picture here. Sometimes it would go through, boom, it would bounce, it would hit back. And remember, these particle emitters are a positive charge. If these particle emitters are a positive charge, if this goes through as a positive charge, a positive and a positive are going to reflect. So when this would hit the center of the gold foil, boom, it would bounce back. So therefore it was hitting something in the middle. If it hit maybe to the edge, it would glance off to the side, it would refract. If it didn't hit anything, it would go straight through because it was just a positive charge. So therefore, because that positive charge and you got the negative electrons around it, it didn't hit anything. So that told him that the nucleus, there's a nucleus inside this atom, therefore it has a positive charge, which is what we call the proton. So Thomson was the electron, the negative was the magnet and the beam. The gold foil experiment was Rutherford. A positive charge hits the center, so therefore the nucleus must have protons in it, must have a positive charge. That's why we call it that. So that's Rutherford. The next guy we look at, or just to summarize Rutherford's findings, Rutherford says the nucleus is small, the nucleus is dense, the nucleus is positively charged. It's very small, it's dense though. So if it's dense, there's really not, we don't have a whole lot going on here. That's why a bunch of the particles just went straight through on the gold foil experiment. On this one, all right, with what he's saying, these are three things we need to make sure we remember. Nucleus is small, nucleus is dense, it's positively charged. You see here, this is something I know we all know together. Electrons have a charge of -1. Protons are +1. We know a neutron, the root word is neutral, so therefore it has no charge. Mass number of an electron is 0 because an electron is like 3.11 times 10 to the -29 grams. Super, super, super duper small. So we're not going to have a mass number for that. The proton's a little bit larger, so proton is 1, neutron is 1. So the electrons are much smaller than the protons and the neutrons. Niels Bohr. Niels Bohr goes on to give us what he called, when we looked at Niels Bohr, he gives us the Bohr model of the atom, and it almost looks like planets rotating around the sun. Okay, so that was Bohr's model of the atom. And this is kind of true today. If you ever watch Big Bang Theory, this is kind of what you see. But the thing is with all of these guys, we technically don't know where those electrons are. It's called the Heisenberg's uncertainty principle, which we'll get into a little bit later. But we do know they have some of these orbitals, they have some different places these electrons are going to be, and this is essentially what it would look like if we were going to put it on paper. A couple of these other guys we're not as worried about for you guys. So that's it right there. What you're going to do now is go complete a little bit of a web quest that I've given you for the atomic model. And there's a few questions about these guys, about these different scientists. You'll click on some of the links, answer those questions. If a couple of the links don't work, you can use your own research to help you answer those questions. I'm fixing to make the second video for Wednesday, which I will post Wednesday morning. Thank you.